Hey, what's up? I hope you're doing great. My name is Daniel Carrion, and today I want to talk about one of my favorite topics, first degree equations. But before that, we will go over some basic concepts. An equation is an equality between two expressions. This means that this here equals the same as this here, which is why it has an equal sign in the middle. They also have a variable which has been a letter whose value we do not know. In addition, its variables would always be raised to the first power. This means that quadratic or cubic terms would not appear. Something very important that I want to clarify is that when we say that we're going to solve an equation, it means that we're going to find the value of the variable. We are going to see equations of the first degree. We will start with simple ones and then with more complicated ones. Let's see our first example. Here I have that x plus 5 equals 15. The first thing I have to do to know how much the x is worth is to clear it. That means we have to leave it alone. The x stays here and this is equal to 15. As you can see, the plus 5, I did not put it anywhere because I have to remove it and I have to pass it to the other side of the equal sign, so the x remains alone. This plus 5 is adding, so it passes to the other side of the equal sign, doing the opposite of adding, which is subtracting. Therefore, it remains as negative 5. When doing the operation, we have that x is equal to 10. To know if our result is correct, we must substitute. This means that I'm going to copy the equation exactly the same. Instead of putting the x, I'm going to put its value. I have the original equation, that is, x plus 5 equals 15. Instead of putting the x, I'm going to put its value, which is 10. So it remains as 10 plus 5 equals 15. When adding 10 plus 5 gives me 15, and this is equal to 15. Therefore, we can say that our result is correct because both sides of the equation are exactly the same. Very easy, right? Let's see another example. Here I have x minus 8 is equal to 30. Since I want to know how much the x is worth, I have to clear it, so I have to leave it alone. I have that x is equal to 30. The negative 8 that is subtracting passes to the other side of the equal sign. When we pass a number to the other side of the equal sign, it has to pass doing the opposite. In this case, it is subtracting, so it passes to the other side of the equal sign, adding. And I have that x is equal to 30 plus 8. Therefore, I have that x is equal to 38. To know if my result is correct, I have to substitute. Then, I copy the same equation. X minus 8 is equal to 30. Now I put 38, which is the value of x, minus 8 is equal to 30. When subtracting 38 minus 8, it gives me 30, and this is equal to 30. Therefore, I can say that the result of my equation is correct because both sides are the same. Very easy, right? Let's see another example. Here I have that 4x equals 36. When there is a number next to the x, as in this case, it means that it is multiplying it. In order to clear the x, I have to remove that 4. And I have that x is equal to 36. The 4 that is multiplying the x passes to the other side of the same, doing the opposite of multiplying, which is dividing. I have that x is equal to 36 divided by 4. When I do the division, I have that x is equal to 9. To see if my result is correct, I have to substitute and put the same equation. 4x equals 36. Now I'm going to substitute. This means that instead of putting the x, I'm going to put its value. And 4 times 9, which is the value of x, is equal to 36. When performing the 4 times 9 operation, it gives me the result of 36, and that is equal to 36. Therefore, my result is correct because both sides of the equation are the same. Very easy, right? Here I have our next example. And I have that x over 7 is equal to 4. To know how much x is worth, I have to clear it. That means it has to be left alone. So I have that x is equal to 4, and the 7 that I was dividing passes to the other side of the equal sign, doing the opposite of dividing, which is multiplying. And I have that x is equal to 4 times 7. When performing the operation, I have that x is equal to 28. To check that my result is correct, I have to substitute it in the original equation. And I have that x divided by 7 is equal to 4. Now, I have 28, which is the value of x divided by 7, is equal to 4. By dividing 28 over 7, it gives me 4 as a result, and the other 4 comes down exactly the same. I can say that my result is correct because both sides of the equation give me the same thing. Very easy, right? Let's see another example. Here I have x plus 1 is equal to 10x plus 10. The first thing I'm going to do is to put my equal sign down here. And now I have to put the similar terms together. In this case, I have several x's. I have to put all my x's on the left side. This x remains on this side. And the 10x that is on the right side of the equal sign is adding. Here it has an imaginary sign. It is adding, so it passes to the other side of the equal sign, doing the opposite of adding, which is subtracting. And I have x minus 10x and the equal sign. Now we lower this 10 here, and this plus 1 that is adding passes to the other side of the equal sign, doing the opposite of adding, which is subtracting. Now I have that x minus 10x is equal to 10 minus 1. As you already noticed, I put the x's on the left side and the numbers that do not have any letter on the right side. Now, if I am going to add the same terms, x minus 10x is equal to minus 9x, and 10 minus 1 is equal to 9. Now I have to solve for x. That means I have to leave it alone. And I have that x is equal to 9. The minus 9 that was multiplying at x passes to the other side of the equal sign, doing the opposite of multiplying, which is dividing. And I have that x is equal to 9 divided by minus 9. When doing the operation, I have that x is equal to negative 1. To know if my result is correct, I have to substitute it in the original equation. And I have that x plus 1 is equal to 10x plus 10. Now, instead of putting the x's, I am going to put their value. And I have that minus 1, which is the value of x plus 1, is equal to 10 times minus 1, which is the value of x, and this is plus 10. When adding minus 1 plus 1 gives me 0 as a result. This is equal to 10 times minus 1 plus 10. So I have 0 equals 10 times minus 1 equals minus 10. And plus 10 goes down exactly the same. I have that 0 is equal, and negative 10 plus 10 is equal to 0. 0 is equal to 0. As both sides of the equation are equal, the result is correct. Very easy, right? Let's see our last example. Here I have that 10x minus 5 plus 3x minus 6 equals 10x plus 10. The first thing I'm going to do is add the same terms of each side of the equation. In this case, I have 10x plus 3x is equal to 13x, and minus 5 with minus 6 gives me minus 11, and this is equal to 10x plus 10. Now I'm going to join the x's on the left side. The 13x stays on this side. The 10x that is adding passes to the other side of the equal sign, doing the opposite, which is subtracting. And this is equal to this 10 that I lower here, and the minus 11 that is subtracting passes to the other side of the equal sign, doing the opposite of subtracting, which is adding. 13x minus 10x is equal to 3x, and 10 plus 11 is equal to 21. Since I want to know the value of x, I'm going to clear it. X is equal to 21. The 3 that's multiplying the x passes to the other side of the equal sign, doing the opposite of multiplying, which is dividing. X is equal to 21 divided by 3. When performing the operation, I have that x is equal to 7. To see if my result is correct, I have to substitute the values of the x in the original equation. I have that 10 times the value of x, which is 7, minus 5 plus the value of x, which is 7, minus 6 is equal to 10 times the value of x, which is 7, plus 10. When doing the operations, it looks like this. 10 times 7 is equal to 70. The minus 5 goes down, and 3 times 7 gives me 21. The minus 6 goes down, and this equals 10 times 7, 70, and plus 10 goes down, adding 70 minus 5 plus 21 minus 6 gives me 80, and 70 plus 10 equals 80. Since both sides of the equation are equal, I can say that my result is correct. Then, I'm going to leave some exercises for you to solve. I hope to see your answers in the comments below. I really hope you like this video. Please hit the like button, comment, share, and subscribe to be able to keep watching my videos. See you next time. Bye bye.